Olá, bom dia a todos, estamos ao vivo, estamos no ar para mais uma apresentação do ABSpk pelo Brasil, essa iniciativa da Associação Brasileira de Sprinklers, que tem como objetivo levar informação técnica a todos os profissionais, estudantes do nosso mercado nacional. Tá? Vamos para mais uma live internacional, logo à frente vou apresentar os convidados de hoje. Mas antes de iniciarmos com essa apresentação, peço para você que já está na live, são 22 pessoas, deixe a cidade que você está acompanhando, a empresa que você trabalha, o nome, e aguardamos o resto do pessoal entrar na live, tá bom? Aqui já tem alguns. Carlos, de BH, seja bem-vindo, Carlos. Bom dia, Silvia. Muito bom. Tem uma turma que vem acompanhando todos os episódios desse mês de novembro. Agradeço, pessoal. Michel. Paulo Floriano, nosso presidente da ABSpk. Seja bem-vindo, Paulo. Bom, pessoal. Vamos lá. Para fazer essa abertura inicial, eu vou chamar no painel principal os convidados de hoje e aguardamos mais um pouco para o início da apresentação, tá? Para o palco principal, eu chamo José Carlos Paiva, gerente executivo da Associação Brasileira de Sprinklers. Convido também Alejandro Garcia, gerente da Latam, falando diretamente de Miami, da Latam, da Viking, né? Gerente regional aí da Latam, Latinoamérica. Chamo também o Igor, responsável técnico da CPEC. Vai dar o suporte para todos nós durante a apresentação de hoje. Seja bem-vindo, Igor. E o nosso palestrante de hoje, Shawn Kramer, diretor de engenharia e serviços técnicos da Viking, falando diretamente de Michigan, Estados Unidos. Muito bem-vindo, Shawn. Bom, pessoal, agradeço a presença de todos vocês. E para fazer a abertura inicial, eu passo a palavra para o Paiva. Paiva, fica à vontade para fazer essa abertura inicial e passar a palavra para os convidados.
Bom dia a todos. Estamos aqui no nosso quarto episódio de uma série que tem os 5 principais fabricantes de sprinklers que operam aqui no Brasil. Hoje é a Viking. A Viking é uma multinacional fabricante de sprinklers, é associada nossa desde a fundação. E ela não fabrica só sprinklers, ela fabrica válvulas, fabrica outros componentes para os sistemas de sprinkler, todos certificados, todos de qualidade. E desde antemão já agradeço a disponibilidade do Shawn em oferecer mais esse conteúdo. Hoje nós vamos tratar de alguns aspectos de projeto que não envolvem armazenagem. E também agradeço ao Igor, que é o distribuidor da Viking aqui no Brasil, da CPEC, também sempre com bastante apoio às ações aqui da ABSpk. Esse evento aqui é o ABSpk pelo Brasil, é um evento que pretende trazer para todo o mercado a importância de se ter um sistema confiável. Isso significa ter um bom projeto, ter uma boa instalação, ter produtos de qualidade, produtos certificados, e depois do sistema instalado, garantir que a gente tenha os procedimentos de inspeção, teste e manutenção no sistema, para que ele, quando requerido, opere e proteja patrimônio e principalmente vidas. Eu agradeço, então, a participação de todos que estão no YouTube agora e desejo ao Shawn uma boa apresentação e reitero aqui o agradecimento ao Igor da CPEC, tá bom? Bom evento a todos e contem com a ABSpk para qualquer dúvida que vocês tiverem, qualquer aspecto comercial, técnico, enfim, a ABSpk está à disposição do mercado para sempre ajudá-los e orientar as melhores procedimentos.
Maravilha. Alguns problemas de sons, mais tranquilo. A internet é assim. Pessoal, antes da gente iniciar a apresentação, quero deixar um combinado aqui com vocês. A apresentação vai ser em inglês, vai ficar salvo no canal do YouTube, vai ter a legenda. De qualquer forma, o Igor, como já apresentado, vai estar dando suporte durante a apresentação, junto com o Alejandro. Então, português, espanhol, inglês. O objetivo é conseguir passar essa informação para todos que vêm acompanhando. Então, quem tiver algum tipo de explanação, abordagem, pode passar ali no chat, a gente faz uma interrupção, tenta passar essa informação para o Shawn, ou se não, como de costume, no final da apresentação ali, a gente abre para algumas perguntas, alguns questionamentos, e a gente faz essa tradução, traz essa resposta com calma para todos vocês, tá bom? Igor, Alejandro, Shawn, fiquem à vontade para apresentar a palavra com vocês. Qualquer coisa é só chamar, tá bom? Já vamos subir a apresentação, um momento só. Mas se quiser já conversar, falar alguma coisa, fica à vontade. Alejandro, por gentileza... Ah, não, já está por aqui. Vamos lá. Qualquer coisa é só chamar, pessoal. Só licença. Igor, Alejandro, Shawn, pode passar a palavra para iniciar a apresentação. Fique à vontade.
Hey, Shawn, you can start.
I think you're muted, Shawn.
Yes, I'm muted, and I'm going to have to share my screen a minute again. So bear with me a second. It wouldn't let me pull it back up, so.
Um momento, pessoal, estamos fazendo um ajuste aqui.
Okay, just want to make sure everybody can see my screen okay.
Yes.
Okay. Bom dia, everyone. My name is Shawn Kramer. Today we're going to be looking at extended coverage sprinklers and going over different requirements for the extended coverage sprinklers, how they can be beneficial, and some considerations that need to be made when we're looking at using extended coverage sprinklers. So we'll start out, we'll look at some of the UL 199 requirements. That's the standard for automatic sprinklers for fire protection service. So UL 199 now actually covers commercial sprinklers, both standard coverage and extended coverage sprinklers. It also had incorporated into it recently. Now it covers residential sprinklers as well as storage sprinklers also. So UL 199 is your overall standard for your automatic sprinklers for fire protection service. And today we're going to look at it based upon the testing requirements for extended coverage sprinklers. Although some of these tests we'll look at, they're done for all the different kinds of sprinklers as well before a sprinkler would obtain a UL listing. We're also going to focus on NFPA 13 requirements for extended coverage sprinklers. So in NFPA 13, you can have a lot of different occupancy hazards in which an extended sprinkler can be installed. You can also see them potentially installed in NFPA 13R applications. We won't focus on that today, but there is criteria in NFPA 13R for your buildings up to 4 stories in height that allow extended coverage sprinklers as well. So when we look at extended coverage sprinklers, there's a couple things that need to be taken into consideration before selecting an extended coverage sprinkler for a certain application. One would be the thermal sensitivity. Do you need a quick response sprinkler or a standard response sprinkler for that application? And when we look a little bit closer at the testing criteria, you'll notice that some of the extended coverage sprinklers have both a quick response listing and a standard response listing for the exact same sprinkler. And when we get a little bit further into the testing criteria, I'll explain how that can be, where you're looking at a data sheet for an extended coverage sprinkler, and on the approval chart, it might say quick response for some of the applications for the sprinkler, where it says standard response for others. Looking at the different applications where we can see extended coverage sprinklers, dry sprinklers are a possibility for extended coverage, where you're in a heated area and you're extending into a non-heated area, whether it's a sidewall or whether it's an upright or pendant sprinkler. There's possibilities for that. Storage sprinklers, we're not going to get into storage too much today, but if you look to the right, with the image that's on this slide, that's the Viking VK595. It's a 25.2 K factor upright sprinkler. And not only can it be used in extra hazard applications for extended coverage, but it also can be used for storage configurations, both as a control mode density area sprinkler or a control mode specific application sprinkler in storage arrangements based upon the current edition of NFPA 13. You can also see special sprinklers that can be listed as extended coverage. So in this example, I'm showing institutional sprinklers here, where you can see the sidewalls or the pendants for your institutional tamper-resistant sprinklers being used as extended coverage sprinklers as well, or as standard coverage. So there's, outside of your standard commercial sprinklers that you see for extended coverage applications, there's other applications and other sprinkler types that can be used as extended coverage as well. When we start to look at the different K factors that are out there for your extended coverage sprinklers, you start with your smaller K factors, your 5.6, your 8.0 K factor. A lot of those extended coverage sprinklers, what we'll see is they're just listed for light hazard applications. And that's because we're extending the spacing of these sprinklers beyond what you can achieve with a standard coverage sprinkler. So in these cases, if you are spacing them out at, say, 20 feet by 20 feet, 400 square foot coverage area, you would require a very high pressure with the 5.6 or your 8.0 K factor if you were trying to use it in an ordinary hazard application with the increased densities that would be required. So once we start to get into the ordinary hazard, extra hazard, or ordinary hazard extended coverage applications, now we start looking at a little bit larger K factors, and you're going to start to see your 11.2 K factors for your ELO sprinklers. You'll also run across 14K for your K factor size. That's a common range for your ordinary hazard applications, where you can see the 11.2 and the 14K. However, you can even go beyond that. There's, like I was saying, the image shown here, that's a 25K upright sprinkler for extended coverage. Now, 25K factor for ordinary hazard, that's a little bit too large of a K factor, but there might be a situation where you don't have a lot of pressure and it might be beneficial. But mostly we're going to be looking at the 11.2 and 14K for ordinary hazard. The 25K upright is commonly used in extra hazard applications, where you want to get the benefit of having the larger spacing of the extended coverage sprinklers over your standard coverage. When we look at the different hazard classifications, you have your light, ordinary hazard group 1 and group 2, extra hazard group 1 and group 2 as well, and then storage for your extended coverage sprinklers. And the orientation for them could be either pendant, upright, or sidewalls. There's a mix and match of all the different orientations that are available for your different types of sprinklers. And then when we talk about how the sprinkler is going to be installed or how it's listed as an assembly, we have our standard, where you have your 1 to 12 inches in non-obstructed construction, where you just have a standard pendant or upright extended coverage sprinkler that could be used for that application. We also have our recess sprinklers. So anytime you're installing it with a recess discussion, we have our push-on style as well as our thread-on style that are offered. The sprinkler and the escutcheon will be listed together as an assembly in those type of applications. You can also see your flush sprinklers where you can see the element, but it's flush up with the ceiling itself. And that, in those cases, is still listed as an assembly because you're going to have a sealing ring that's going to go around the sprinkler as well to cover up the hole, and that's part of the listed assembly for the sprinkler. And then lastly, we have our concealed sprinklers that can be used for extended coverage as well. With the concealed sprinklers, similar to the flush sprinklers, it's listed as an assembly. So the sprinkler itself, along with whatever cover plate options are available. For example, you could see a smaller diameter cover plate, larger diameter cover plate, square cover plates. There's quite a few different options depending upon the specific sprinkler that you're looking at when you're using a concealed sprinkler in an extended coverage application. However, it's always going to be listed with the cover plate. So without the cover plate, it's not a listed assembly. When we start to look at UL 199 and how UL breaks down the coverage areas for extended coverage sprinklers, we'll start by looking at the section in NFPA 13 2025, which is the latest edition just recently released for NFPA 13. And it's always stated the maximum coverage area of any sprinkler shall not exceed 400 square feet. Now, when you look at pendants and uprights, if you can't exceed 400 square feet with a pendant or upright extended coverage sprinkler, it's always in the middle of its coverage area. So if you think about it, your 20 by 20 is 400 square feet. So since your uprights and your pendant sprinklers are always in the middle of the coverage area, you wouldn't be able to extend that coverage beyond 20 feet in either direction. And based upon UL 199, they're always listed in 2-foot increments. So you start out with your 12 by 12, 14 by 14, 18 by 18, all the way up to your 20 by 20 as possible options for the spacing of these sprinklers. Now, when you start to look at the different hazard classifications that they're listed for, you'll see that certain spacing you wouldn't have listed for light hazard applications. For example, with a standard coverage sprinkler and a light hazard application, you can already go up to 225 square feet, 15 by 15 maximum spacing. So if you look at your 12 by 12 and 14 by 14, you'll see that I noted that those are for ordinary hazard applications where you're going to see those extended coverage sprinklers. Because there's really no point in using an extended coverage sprinkler for a 12 by 12 or 14 by 14 spacing, because you can already get up to a 15 by 15 spacing in that hazard classification with a standard coverage sprinkler. Now, ordinary hazard limits you to 130 square feet for a standard coverage sprinkler. So even the 12 by 12 option would allow you greater spacing at 144 square feet, or the 14 by 14 up to 196 square feet. And the one we were looking at on the previous slide with the 25K upright that can be used for extra hazard as well as storage applications, that one can go up to a 14 by 14 spacing with 196 square feet. So now once we get above the 15 by 15, the 225 square feet, into your 16, 18, and 20 foot spacing, now we'll start to see extended coverage sprinklers for light hazard applications. Now, that's not saying that these ordinary hazard extended coverage sprinklers that we have listed for the 12 by 12 and 14 by 14 are limited to those spacing. We actually have those going up to 20 by 20 as well. Just keep in mind when you have ordinary hazard application and you're going extended coverage at your greater spacing, the approval chart's going to show that you're going to require quite a bit more flow as well as a higher pressure because of the higher density that needs to be provided in those applications. Sidewalls can get a little bit different because unlike uprights and pendants, when we look at an extended coverage sidewall, it's still restricted to that 400 square feet maximum spacing. And it's always going to be listed in 2-foot increments, just like what we saw with the uprights and pendants. However, since a sidewall is coming out from the wall, when you look at the coverage area of a sidewall, you're looking at the width of the coverage. So the sidewalls that are spaced between each other along the wall in which they are installed on. And then you're also looking at the throw of the sprinkler. How far can it protect out from the wall in which it's installed on? So instead of having always 16 by 16 or always a 20 by 20 spacing like you would with your uprights and pendant sprinklers, because you're always in the middle of the coverage area, with sidewall sprinklers, you can see dissimilar spacings as we have shown here. For example, a 14 by 24. So anytime you're looking at an extended coverage sidewall sprinkler, and take, for example, the 14 by 24 spacing that we're looking at here, the 14 feet means in between the sprinklers that are spaced along the wall. So 7 feet on each side is half the listed spacing between the sprinklers. Now, however, we're able to throw out up to 24 feet because we're spacing 14 feet in between them along the wall, and you'll see the coverage area is 336 square feet for that application. So you can see where it goes all the way up to 14 by 26 feet. That would allow you to get a 26-foot throw. That's a very common application for hotels, where you just have a sidewall protecting most of the hotel room, where it can throw up to 26 feet, and you're able to protect it with just one sidewall sprinkler instead of 2 that would be required for pendants. Because if you have a room that's 24 feet long, you got to remember that your pendants can have a maximum spacing of 20 by 20. So you would always be required to at least 2 extended coverage pendants in that application, where the sidewall with the greater distance on the throw allows you to achieve what's required with only 1 sprinkler for each of those rooms. Now, I was talking about with the width and the throw. In most applications, you're going to see where the width is lesser than the throw of the sprinkler when we're looking at sidewall sprinklers for extended coverage. But you'll see on the bottom there, I have 2 spacings where it shows 28 by 12 and 28 by 14. So there are sidewalls out there that are offered that would have a greater width along the wall than a throw. They're commonly referred to as corridor sprinklers, where you might have a long corridor that you're protecting, and it's not that wide. It's no wider than 12 feet or 14 feet. So you don't necessarily have to achieve that long throw like the 14 by 26 that we were looking at when you're protecting a hotel room. In a corridor, it would be beneficial to have greater spacing along the wall in which the sidewalls are installed on than necessarily the throw out. And keep in mind, just because they're referred to commonly as corridor sprinklers, they're not restricted to just being installed in corridors. Any type of configuration where you might have an application where it would be beneficial to have the width greater than the throw, you would be able to use that sprinkler for that application. When we start to look at UL 199 for the thermal sensitivity, this is how we determine whether a sprinkler achieves a listing as quick response or as standard response. So going back to the start of this, where I was talking about that you could have the same sprinkler that's both listed as standard response and quick response, and it's the exact same sprinkler. Otherwise, these thermal sensitivity tests in UL 199 are what's going to drive that and make that determination whether a sprinkler is going to receive a standard response listing or whether it's going to achieve a quick response listing. And the first test that would be done to make this determination on its thermal sensitivity would be this plunge oven that I have shown here. So in the plunge oven, you can kind of see the tops laid back and there's a hole in the top. So what happens is the sprinkler would be installed into that cover, and then the air is moving through that plunge oven at a constant velocity and at a specific temperature rate of rise. So the test starts once you close that cover, and then the time's going to start to the operation of the sprinkler. So for example, if you're trying to achieve a quick response listing with the plunge oven test, for a quick response, you'll see that you have to operate the sprinkler within 14 seconds. To be able to pass the UL 199 test for the plunge oven to achieve standard response, you would need to activate that sprinkler within 100 seconds. So that being said, this is where we can kind of see the same sprinklers have both a quick response or standard response listing. So for example, if you have a 155-degree ordinary temperature rated sprinkler and you do the plunge oven test and it operates within 12 seconds, then you're able to achieve a quick response listing based upon this test. There's another test that I would need to pass as well that we'll look at, but this would be the first step to being able to achieve that. Now, on the other hand, if you have a 175-degree rated sprinkler, let's say it operates in 20 seconds, well, that doesn't meet the 14-second requirement for the plunge test. So in that situation, it would be a standard response sprinkler. So you could see a 155 of the same sprinkler temperature-wise getting a quick response listing, where the 175-degree temperature of that sprinkler might have a standard response listing. So that's something to keep in mind, and this is one of the tests that's used to make that determination. The other test is your room fire test. So you can see the detail here. This is out of UL 199, where you have your fire that started on a wood crib on a pan of heptane over in the corner of the room, and then you're going to have your sprinklers spaced out at whatever the desired spacing is for those sprinklers, and you're going to start the fire and see how quickly they operate. So this is your other thermal sensitivity test to determine whether a sprinkler is going to be a standard response sprinkler or a quick response sprinkler. So you can see this one kind of varies a little bit. For example, you have just shy of 4 minutes for a ordinary temperature sprinkler and light hazard to pass the standard response requirements. If it's intermediate temperature in a light hazard application, you have just over 3 minutes for it to activate. If it's ordinary temperature in ordinary hazard, you have 2.5 minutes. Where now, if it's an intermediate temperature rating in ordinary hazard, you have 2 minutes for it to operate. So you can see it kind of varies based upon what the temperature classification is, as well as what the hazard is that you're looking to protect, and it can vary a little bit throughout that. Similar to the plunge oven, if you're not able to pass these room fire tests with a quick response listing, it would be considered standard response as well. So you have to be able to pass both the plunge oven test as well as this room fire test within the restraints of the quick response criteria in order for it to achieve a quick response listing. So when we look at this thermal sensitivity room fire test for quick response, you can see that those numbers are reduced drastically as far as how long you have for the sprinkler to operate. And you can see it's kind of tied into both your ordinary and intermediate temperature ratings. For example, you have 75 seconds, so just over a minute in a light hazard application for both ordinary and intermediate temperature classifications. You have 55 seconds if you're trying to get the listing for an ordinary hazard application for both your ordinary and intermediate temperatures. So if we go back to the standard response, you can see even the most restrictive time frame for a standard response sprinkler started at 2 minutes and went up almost all the way to 4 minutes. To achieve that quick response listing, you're just over a minute for your light hazard, and you're just less than a minute for an ordinary hazard. So both these tests have to be passed per UL 199 to achieve a quick response listing or a standard response listing, depending upon the time frame in which they activate for whether it's a standard response or quick response sprinkler for light or ordinary hazard. When we start to look at the water distribution test, so we looked at thermal sensitivity, that ties into your quick response, standard response listing. Now we're starting to look at the coverage area of the sprinkler and how that's measured as per UL 199. Well, your water distribution test is one of those required tests to determine the protection area of the sprinkler. So one of the requirements is anywhere within the area that you're protecting, so whether it's 18 by 18 or 20 by 20 of your coverage area, you have to be able to wet the walls within that protection area 30 inches up above the floor. So what you'll see with extended coverage sprinklers is they have a little bit of a tighter spray pattern initially when they start spraying out, because they have to be able to wet the wall 30 inches up above the floor. So this ties into obstructions, which we'll look at a little bit later. Because of that higher, tighter spray pattern that we're looking at, we have to take obstructions that are closer to the sprinkler into a little bit further consideration than you would with your standard coverage sprinklers, where you might have obstructions that can be a little bit closer to them because you get more of the umbrella type spray pattern starting sooner with your standard coverage sprinklers than you do with your extended coverage sprinklers. Also with sidewall sprinklers, the wall in which they're installed on, they have to direct part of their spray pattern back at that wall to wet the wall that they're installed on. So in this case, with an extended coverage sprinkler, it has to direct 3.5% of that discharge back upon the wall in which it's installed to wet the wall behind it, if there are any combustibles on that wall that may need to be wet down in the event of a fire. Also, lastly, one of the other things that's looked at is the wall surface between the sidewall sprinkler shall be completely wetted from the floor to within 4 feet below the deflector in the entire coverage area of the room in which it's tested. So here's an example of what we look at in the room that's used per UL 199 for your water distribution test. Same room is going to be used whether it's a pendant or a sidewall sprinkler, and you still have those same requirements. So when you're looking at a pendant sprinkler installed in the middle, it has to wet the wall 30 inches up from the floor in its coverage area. But now it's installed in the middle, so that's a little bit easier than the sidewall. Whereas going back to that 14 by 26 coverage area, the sidewall for this example would have to be able to throw out 26 feet for its coverage area. And even at that 26 feet out, it still has to be able to wet the wall 30 inches up from the ceiling. So once again, once we start looking at obstructions, keep in mind this requirement. That's what drives part of your obstruction rules here. Because if you're trying to throw out 26 feet and hit that 30 inches above the floor, your sidewall protection, your spray pattern actually arcs up a little bit before it starts coming down. So with obstruction rules with sidewall sprinklers, what you'll see is that there's that 8-foot area that you want to keep obstructions out from with an extended coverage sidewall sprinkler. And that's because the pattern starts to arc up a little bit initially before starting to drop off for your floor protection. Now, lastly, we see that there's all these pans down below in this room, the collection pans that we're looking at here. Now with the collection pans, they're each 1 square foot. So if you were trying to achieve a 20 by 20 spacing on a pendant sprinkler, you'd have 20 by 20 of those pans spaced out. And what you're doing is you're measuring how much water is being provided in a certain amount of time. So based on whether you're trying to achieve a light hazard listing or an ordinary hazard listing, there's going to be a different amount of water that needs to be collected in those pans over a specific amount of time. So once the sprinkler is flowed, each of those pans are measured to make sure that you have the appropriate amount of water, amount of density collected in those pans over the time of the testing. And this is crucial to point out because we get a lot of requests for spray patterns. And the spray patterns will show that a sprinkler actually sprays further than its listed coverage area. And that is the case. It will spray further, but this is a good point to go over it, a good time to go over it, because even though it sprays further, it hasn't been measured to make sure that you're getting that proper density beyond what it's listed for. So if you have a sprinkler listed for 16 by 16 spacing, and the spray pattern shows that it actually sprays up to 20 by 20, keep in mind, it's only been tested for that 16 by 16 spacing to make sure enough water is being provided from its spray pattern to meet the requirements of the density for whatever hazard classification you have in that situation. So even though it shows that it goes 4 feet beyond its listed coverage area, you might not have the proper density beyond that for the spray pattern for the water that's being provided. So that's why spray patterns, we provide them, but they're not really relevant because they show outside of what the sprinkler's been tested for. Even though it'll spray that far, it doesn't mean it's providing the adequate density outside of its listed coverage area with the spray pattern and what it's showing. So when we start to look at NFPA 13 requirements, one thing I want to point out, you'll see that we're looking at Chapter 11. So if you're familiar with the 2016 edition of NFPA 13 or older, all this criteria would have been in Chapter 8. Chapter 8 covered your obstructions, your spacing requirements, and all that for both your standard, extended coverage, residential, storage sprinklers. Everything was in Chapter 8. Well, in 2019, with the reformat of NFPA 13, it was divided up into specific chapters for different types of sprinklers. So Chapter 11 is your chapter for the installation of extended coverage sprinklers. We'll also see a little bit further on in this presentation that you have Chapter 19 for your design criteria for your extended coverage sprinklers as well. So here we see in section 11.2.1 of NFPA 13/2025, one of your installation requirements for extended coverage sprinklers, unobstructed construction consisting of flat, smooth ceiling with a slope not exceeding a 2 and 12 pitch. And you can go to the technical data sheet for the design criteria of each sprinkler, and it's going to tell you requirements based upon anything that might go above and beyond NFPA 13, as well as offer you some criteria that is in NFPA 13 for those sprinklers as well. So for this example, we see it's limited to light hazard occupancies with a smooth, flat, horizontal ceiling only. So 2 and 12 is your determination for what's considered a horizontal ceiling. So when we talk about slope ceilings, that would be anytime you exceed a 2 and 12 pitch, whereas if it's 2 and 12 or less, by definition in NFPA 13, it's considered a horizontal ceiling. Also looking at another example here in section 11.2.1 of NFPA 13/2025, talks about extended coverage sprinklers can be installed in unobstructed or non-combustible obstructed construction where specifically listed for such use. So for this example, you can see that going to the design criteria for this specific sprinkler, that it says that you are able to install it in non-combustible obstructed construction, and then it gives you the parameters in which you're able to install it in that type of installation. So that would be applicable to this section in NFPA 13. You can also see with sidewall sprinklers, for example, sidewall sprinklers installed on slopes exceeding 2 and 12, which is your horizontal ceiling, are allowed where listed for such use. Once again, we're going back to the technical data sheet to the design criteria to see if that sprinkler might have a listing that goes above and beyond what's called out in NFPA 13. So in this example, we can see with the VK605 sidewall sprinkler extended coverage, you're able to install it up to a slope of a 4x12. So that would exceed your 2x12 horizontal ceiling, and that can be found in the design criteria on the technical data sheet for that specific sprinkler. Can also see sidewall sprinklers installed on slopes exceeding 2 and 12 need to be installed in accordance with section 11.3.521. So looking at that section, it states that sidewall sprinklers were installed under a slope ceiling with a slope exceeding 2 and 12 shall be located at the high point of the slope and positioned to discharge downward along the slope. So you can see on the right-hand side, that's an escutcheon. It's the G1 where it actually is used for slope ceilings, so that the escutcheon cup, you can get a nice aesthetic look where it's still flush with the wall, but you're able to position the sprinkler discharge downward along the slope and keep your deflector parallel with the ceiling while still having a nice flush look with the escutcheon cup up against the wall. Moving on with different listings for extended coverage sprinklers, you can see a few additional requirements where you can install them within trusses or bar joists, having web members not greater than 1 inch, where the trusses are not spaced greater than 7 feet 6 inches on center, or having a slope exceeding 2 and 12. Also, upright and pendant sprinklers under smooth flat ceilings having slopes not exceeding 4 and 12, where specifically listed for such use. So that goes back to the VK605 that we were just looking at the design criteria for, that had that listing up to a 4x12 slope. And then lastly, you can see that they can be installed in obstructed construction in accordance with section 11.2.4.1.2. So that's going to provide you the requirements for an extended coverage sprinkler being installed in obstructed construction. Now, I highlighted this in green because this is actually new to the 2025 edition, and this is a very large change that you will see in this edition moving forward, with not only extended coverage sprinklers, but multiple other types of sprinklers as well. If you're familiar with FM's always had requirements in their data sheets that outside of storage applications, if you had a really high ceiling, you had to go with a larger K factor. You had to provide more water. NFPA never addressed that outside of storage applications. You could have a 60-foot building and install a 5.6 K factor up at the ceiling. Well, the 2025 edition is now somewhat similar to FM, as when you have excessive ceiling heights outside of storage applications, you may have to increase your K factor size, or you may have to provide a higher density based upon what the ceiling height is. So that's going to take a little bit of time to get used to, but this is new to the 2025 edition. So for example, here we see 11.2.1.1. Extended coverage pendant sprinklers having a nominal K factor of 22.4 or less shall not be permitted for use in ordinary hazard group 2 and higher occupancies where the ceiling height is greater than 30 feet. Now, you'll see that it does specifically state pendant, does not state upright, and that's based upon testing that has been performed for these sprinklers at higher ceiling heights. And if you have the 2025 edition of NFPA 13 or access to it, you can read about the testing that was performed in section C7 in the back of NFPA 13. When we talk about the protection area, we're always talking about those 2-foot increments for the protection area. So for example, here we have a room that is 13 feet 6 inches by 17 feet 6 inches. Now, since your pendant is always spaced in the middle of its coverage area, it's going to be the same coverage in both directions. So since you have the 17 feet 6 inches in one of the directions, that means you're up to an 18 by 18 spacing on the approval chart, as we have shown here, with a required flow of 33 gallons per minute at 17 psi. So you always round up to whatever the 2-foot increment is, and when it's a pendant or upright, that's going to be based upon whatever the largest side of the room is, whatever the largest dimension is that we're looking at, to select the appropriate design criteria on the approval chart. So an NFPA 13 provides a table giving you different requirements. You can see unobstructed, for example, you can go up to 400 square feet. In certain applications, the spacing might be reduced based upon the construction type or the occupancy classification. So this table is going to provide you the requirements for extended coverage sprinklers and what their maximum spacing is. Looking at the some more of the spacing and getting into the deflector position, you can see it can be maximum half the listed spacing. So if you're 7 feet off a wall, that means you're using a 14-foot spacing for that direction of the sprinkler. Your minimum distance is 4 inches unless listed for less than that, which that would get into your concealed and recessed sprinklers. Minimum distance between sprinklers is 8 feet unless baffles are used meeting the requirements. And we'll take a little look at what the requirements are for those baffles when you're spacing sprinklers closer together than their minimum listed spacing. And your deflector position, your standard 1 to 12 inches down below the ceiling for unobstructed construction, which doesn't apply to concealed, recessed, or flush sprinklers in accordance with their listing. And in certain occasions, the sprinkler may have other listings that could be used for different ceiling configurations. Once again, you're going back to the design criteria on the technical data sheet to make that determination. So when we look at the baffles, you can see it for extended coverage sprinklers. It's also covered for residential and standard coverage. And it provides you what the requirements of the baffle would be if you're spacing those sprinklers closer together than their minimum listed spacing. So for example, it's got to be made of a solid and rigid material that will stay in place before and during sprinkler operation. Shall not be less than 8 inches long and 6 inches high. So really what it's doing is it's going to be installed there to protect the next sprinkler over that's below its minimum listed spacing from cold soldering that sprinkler in the event of a fire. Another deflector position requirement is based upon change in ceiling elevations. So when you look at a change in ceiling elevation, depending upon what the change is, you might be able to treat it like a wall. So for example, this sprinkler, this example, the wall change in elevation is so great, the ceiling change, that you treat it like a wall. Therefore, you could actually have the sprinkler only 2 feet off on the lower end and 2 feet off on the higher end. Even though that's only a 4-foot spacing, you're treating this like a wall. So that would not be applicable to the baffle requirements that we were just looking at. But on the other hand, when it doesn't meet that elevation change, now you're spacing these two sprinklers like they could potentially be within their maximum listed spacing. So if you have 18 by 18 spacing, these sprinklers could actually be spaced 18 by 18, and that would still be acceptable in this instance because the change in ceiling elevation is not to the extent where you're treating it like a separate area with a wall in between the sprinklers. Same would apply for the minimum distance between the sprinklers as well. When we look at obstructed construction, you have your criterion NFPA 13 talking about when you can install an extended coverage sprinkler with obstructed construction. And really what you're looking at is a 22-inch maximum distance down from the deck with your deflectors 1 to 6 inches below the bottom of the obstruction. So here we have some details with obstructed construction showing your 1 to 6 inch deflector distance below the structural members with a maximum distance down of 22 inches below the deck. And NFPA gives you examples of what's considered obstructed construction as well as non-obstructed. You also can put them in bays with the deflectors at or above the plane up to 22 inches down when the obstruction rules are followed. In this case, you wouldn't have to install a line in every single bay. You can actually skip a bay using this obstruction criteria in NFPA 13 with your extended coverage sprinklers. Now, when you're not able to achieve that, the last thing you're looking at is you would have them installed in every single bay. So if you're not able to achieve that, your last option would be installing them in every single bay with your deflectors 1 to 12 inches down below the deck. When we start to look at obstruction criteria, this is all in Chapter 11 now. We're looking at your obstructions for how far you have to be away to be able to spray below the obstruction based upon your deflector distance down as well as the distance away from the obstruction. And if you look at this detail that follows that table, and this goes back to how I was telling you with the extended coverage spray pattern, you have the higher, tighter spray pattern that needs to develop in order to be able to hit that 30 inches up from the floor. So this is based upon the table and how far you're spaced away. You can see that the spray pattern, how it develops, it actually clears all the obstructions based upon that table on the previous slide. New to the 2022 edition, it was addressed for both pendants and sidewalls in corridors and hallways. Sometimes you get an obstruction that's going to be really close to it, and you can see that this would be allowable, even though you know you're not going to get the spray pattern on the other side of it. It's an allowable obstruction that could be close to the sprinkler in this type of application. For other sprinklers, it's referred to now in NFPA 13 as shadow areas, which essentially is what you're creating here would be a shadow area beyond the obstruction shown in this figure. Other criteria that we can see, whether you have trusses or columns, you have your 4 times rule. So with standard coverage, you have a 3 times rule. With extended coverage, you go up to the 4 times rule. You'll see with trusses, there's still a maximum of 36 inches that you have to be away. But now if you have vertical column that you're looking at, you're applying that 4 times rule, but there's no maximum. So you got to take that into consideration that a few editions ago, the maximum distance was removed for vertical columns, even though it's still applicable for your truss consideration when using the 4 times rule. Ceiling pockets are another thing to look at when we're looking at extended coverage sprinklers. Sometimes ceiling pockets don't have to be protected. And if you go to Chapter 11, it's going to provide the criteria as shown here, saying that you can be up to 1,000 cubic feet. You have to be 10 foot in between them, not exceeding that 1,000 cubic feet, and your depth cannot exceed 36 inches in order to emit sprinkler protection from up in that ceiling pocket. So here's some examples where you wouldn't have to use sprinklers in those ceiling pockets. For example, you're less than 10 feet in between them, but the entire volume of these 3 pockets does not exceed 1,000 cubic feet, so you would not have to protect them. In this case, you're a minimum of 10 feet apart. Now each of those pockets can be up to 1,000 cubic feet each because they're separated by 10-foot minimum or greater. We also have our skylights. Sometimes bigger skylights are going to require protection up within them. In this case, if you're 32 square feet or 32 square feet or less in area, you don't require protection up in the skylight, but it does have some requirements for separation of at least 10 feet horizontally from any other protected skylight or unprotected ceiling pocket. So it's not just skylights. It could be just what we were looking at before. An unprotected ceiling pocket as well. So when we look at our data sheets, you're going to find all the criteria for the spacing on the data sheets. We were discussing earlier that all the listings are in 2-foot increments up to a maximum of 400 square feet coverage area. For sidewalls, you can actually go up to a 28-foot spacing for the throw or the width. We saw that earlier with the corridor sprinkler we were talking about, where you can actually space it up to 28 feet in between them along the wall. So in the table, it provides you the maximum spacing for both light and ordinary hazard for your extended coverage sidewalls. And just like with the pendant and upright sprinklers, based upon your room, you're always going to round up to whatever the next 2-foot increment is based upon the layout of the room. You can also see protection areas for extended coverage sidewall sprinklers with your distance on opposing or adjacent walls. This is one of the bigger changes because it used to say not within the maximum coverage area of a sprinkler. So if you had two sidewalls that could spray up to 26 feet, it was saying you couldn't space them on opposing walls within, what would that be, 52 feet of each other, really, because they couldn't be within the 26 feet. Well, now in the 2022 edition, it was added that you can actually, as long as you're 12 feet apart, that would be acceptable. So that helps clarify opposing and adjacent walls for extended coverage sidewall sprinklers. As long as you're 12 feet apart, it's acceptable to have them on opposing or adjacent walls. And then also you're going to see your different criteria as far as deflector distance down from the ceiling. So here we see listings for 4 to 6 inches and 6 to 12 inches. You might have different flows and pressures based upon that requirement. And it has to be listed anytime it's going to be for lower than 6 inches below the ceiling for a sidewall sprinkler. And that's all that's going to be found right on the technical data sheet. Can also see for your distance off the wall. So your deflector distance can't be more than 6 inches nor less than 4 inches on which they're mounted. However, horizontal sidewall sprinklers can have their deflectors less than 4 inches when they're listed for such an application. This would be your recess escutcheons like what we have shown here with the E1 and the E2 escutcheon, where you can actually have that deflector distance closer than 6 inches off the wall. And you'll see that the X dimension, when we're measuring that, is actually at the start of the deflector. It's not at the end of the deflector. So keep that in mind. That's a common question we get. How do you measure? Do you measure to the end of the deflector or the start of the deflector? NFPA 13 now shows that that measurement would be taken to the start of the deflector. Soffits, when we look at soffits, sometimes you got to install sprinklers below the soffit, other times you don't. In this case, you would not have to because it's 8 inches or less for the soffit, so you can just install the sidewall up at the higher ceiling elevation. And then you also have instances where you might install it below the soffit, and as long as you're still within your deflector distance down from the ceiling as well as below the soffit for its listed range, you're able to achieve that as well without having 2 levels of protection there. And looking at the spray patterns is showing you how a sidewall spray pattern develops. So you can kind of see at the start of it on that back wall there, it kind of arcs up before it starts dropping down. And that's crucial to know why your obstruction rules with these sprinklers are the way they are. And like this example here where it says that you do not want to install obstruction within 8 feet from the sidewall sprinkler. And then it even points out minimum 4-inch clear space with no obstructions in that area, except for the exception in the section reference. And that's because it arcs up before it comes back down. So you want that 4-inch clearance above the sprinkler when you're close to it for how the spray pattern develops. Just like with the pendants, we have the same obstruction criteria for corridors where you can get that small shadow area with a sidewall sprinkler, which is new to the 2022 edition to show that. And you also have your table that's going to show you what densities are based upon what hazard classification. If you'll notice, this is no longer a curve. The 2022 edition actually went away from sprinkler curves. So there's a single point density as shown here, where you're either using a 0.1, a 0.2, a 0.3, and you don't have that curve anymore where you slide up the curve and you can increase the remote area with how many sprinklers are going to operate. It's a single point density for an occupancy classification. We can also reduce our remote area based upon the ceiling height. So the lower the ceiling height, the more of a reduction you can take. This applies to both standard and extended coverage. It has to be a wet pipe system and light or ordinary hazard applications. You can also see with slope ceilings, you have a little bit more criteria now as to how you can protect a slope ceiling. If you can't find a sprinkler listed for it, it gives you an option to install a false ceiling to make the slope so it's not exceeding the listing of the sprinkler. It also gives you other applicable criteria as shown in the section. because now we're into chapter 19 for your design criteria for extended coverage sprinklers. So 11 is your installation criteria, 19 is going to be your design criteria. And you'll see, once again, in the design criteria, it's going to give you requirements for sprinklers for ceiling heights over 30 feet. So you can read through that in this chapter, in chapter 19 in these sections. And for example, you can see where it says sprinklers having a K factor less than 11.2 shall not be permitted for use in ordinary hazard group 2 and higher hazards where the ceiling height is greater than 30 feet. So this will take a little bit to get used to. There's stipulations. Like I said, it doesn't only apply to extended coverage sprinklers. It applies to other sprinkler types as well. It's new to the 2025 edition. So a lot of places, a lot of jurisdictions have not adopted the 2025 edition yet, but it's something to be aware of when a jurisdiction does adopt the 2025 edition. This will be a requirement moving forward. And you can see here that sometimes the density needs to be increased as well. So for example, if you look at C there where it says for OH2 with ceiling height greater than 40 feet, you're looking at a minimum 0.45 density. So we're all used to OH2 being a 0.2 density. Well, in this case, you'd be using a 0.45 density for an OH2 occupancy. So once again, just to reiterate, there's a lot of big changes here that you should be familiar with before jurisdictions start adopting this edition of the standard. And getting into extra hazard occupancies, you still have the same criteria for your high ceiling. So it addresses both light, ordinary, and extra hazard occupancies when you have these higher ceilings. You'll notice with light hazard, it's not affected. It's more affected for ordinary and extra hazard. And that would be it for the presentation. I will open it up to any questions we might have at this time, and I would like to thank you all for your time.
Excelente apresentação, pessoal. Obrigado, Shaun. Vamos para algumas questões que já estão aqui no chat. E lembrando, pessoal, que quem está assistindo quiser o certificado de participação, na sequência vai ter um link, um formulário para preenchimento no chat, tá bom? Igor, Xará, eu vou colocar algumas perguntas aqui, e aí, por gentileza, você e o Alejandro passar para o Shaun responder para a gente, tá bom? Vamos lá. A primeira pergunta é do Edson Júnior. Ele pediu, pode explicar, por favor, o motivo de a OL acertar sprinklers embutidos de resposta rápida e a FM considerá-los sempre resposta padrão? Pergunta do Edson.
Okay. Sean, the first question is regarding concealed sprinklers, and is asking why UL for the 3mm bulb ones, okay? Why UL considers them quick response, but FM does not. So that creates a bit of confusion.
Yeah, so that's been through the history of FM and their testing criteria. It's not that FM doesn't consider them FM. So UL breaks up their testing requirements, whether it's a standard pendant sprinkler or a concealed sprinkler, and has different testing requirements for your thermal sensitivity based upon the type of sprinkler it is. And that allows you to get a quick response listing with a concealed sprinkler, because now you have both the cover plate that has to detach as well as the activation of the sprinkler. FM, on the other hand, FM treats all pendant sprinklers the same for thermal sensitivity. So whether it's a standard pendant with the element exposed or a concealed sprinkler, it's the same criteria. And it's not that FM doesn't allow it. Their testing criteria is so strict, it's so stringent that no manufacturer has a concealed sprinkler that could pass that testing to get a quick response listing with a concealed sprinkler. So that's why you don't see FM approved concealed sprinklers. There has been discussion about potentially changing that as FM branches out a little bit more into residential applications, where they didn't in the past. They were more industrial applications. So it wasn't too much of a concern with concealed sprinklers in that type of environment. If that happens or when that happens, I would not be able to say, but I have heard discussions about that potentially changing. But as it stands right now and until further notice, yeah, you won't find quick response FM approved concealed sprinkler. And that's why.
Thank you.
Igor, você quer fazer um resumo de 3 linhas sobre a resposta? Ou podemos
basicamente,
seguir?
ele explicou que a forma de teste, né? O L testa em separado o sprinkler e a tampa, e a FM considera pendente e põe embaixo do mesmo teste, independente se ele tem tampa ou não. E aí, devido à tampa, acaba demorando mais e por isso acaba que não passa, né? Mas é porque o teste é muito estrito.
Maravilha.
E tem uma discussão grande, porque a FM começou como industrial e agora é bem mais industrial, né? E só que agora tem muita discussão porque tem nos Estados Unidos há muito sprinkler em residência, né? E os residenciais são bem comuns os embutidos, né? Para ficar escondido, né? Para não ficar aparente. E tem uma discussão sobre se vão mudar o teste por conta dessas demandas residenciais ou não.
Maravilha, obrigado. Obrigado pela pergunta, Edson, também. Vamos para a segunda. Fast Company. Como podemos entrar em contato com a Viking para saber sobre detalhes específicos sobre aplicações de produtos? Vocês atendem projetistas?
Okay. Sean, there's a guy asking asking if we answer questions of designers, okay? And also if yes, how can the customers get in contact with Viking to get specific details and orientation on how to use the product?
Yeah, definitely, Igor. We offer any assistance for questions you might have on product selection, application, design requirements, pretty much anything relating to the industry as well in our technical services department. So we have our toll-free number, which might not be as easy to call based upon the language barrier, but that number is 877-384-5464. We also have our technical service email, which we will answer any of those questions as well. It's tech, TECH, SVCS at vikingcorp.com, VIKINGCORP.com. So we're happy to go through and help designers out with any questions they may have. And those are just two of the possible avenues in order to get those questions answered from our technical service department here at Viking.
Ok, thank you. Igor, ele comentou que a Viking está sempre aberta a responder quaisquer questões sobre produtos e também sobre aplicação de normas, né, não específica a produtos, de uma forma geral. Tem um número que você liga para os Estados Unidos, mas só está disponível em inglês. E tem um e-mail também que ele citou, mas também o pessoal só responde em inglês. E aqui eu aproveito para deixar aberto para o pessoal que qualquer dúvida técnica, aplicação de produtos, essas coisas, pode ser tratado com a ABSpk, tá? A gente tem uma equipe aqui de suporte técnico à disposição para atender o pessoal em português da forma mais rápida possível. Algumas perguntas a gente atende de bate-pronto e outras a gente atende trocando informações com a fábrica, caso a caso, tá? Mas é bem tranquilo E eu queria deixar bem claro isso, que a Viking tem um suporte técnico no Brasil também, tá? Pouca gente... Tem bastante gente que não está habituada, né? Então é importante a gente reforçar isso, tá? Eu sou responsável técnico e eu trato com o Sean com bastante frequência.
Maravilha. Obrigado, Igor, Sean, e obrigado à Fast Company pelo questionamento. Eu vou emendar duas perguntas aqui do Cláudio Andrade. Ele faz a pergunta: nos Estados Unidos, os sprinklers mais comuns são os de resposta rápida. Por que aqui no Brasil vemos o contrário, né? E já complementando essa pergunta, qual que é o benefício de usarmos os sprinklers de resposta rápida em instalações comerciais, estacionamento, etc.
Okay, Sean, this is a good question. It's related to non-storage. Okay, so just the glass bulb ones. The guy is asking why in the United States the most common kinds of sprinklers are the quick responses, and in Brazil we see the opposite. We see a lot of standard response and very small quantities of quick response. And he would like to know the difference of both, and would like us to emphasize the benefits of using quick responses in commercial and standard, let's say, daily basis applications like commercial, parking lots, buildings, this kind of things.
Yeah, so quick response sprinklers allow the sprinklers to operate quicker to start controlling or suppressing the fire. So with a quick response sprinkler, what happens, most fires in like light hazard applications, for instance, are controlled by one or two sprinklers. So in those instances, if you have a quick response sprinkler, it's going to activate faster those sprinklers to control the fire. And once the fire is controlled, you're not going to continue to operate sprinklers. Where with standard coverage sprinklers, because of the delay in the activation, you're potentially going to have more sprinklers operate. Therefore, you're going to need more water for those applications. So that's why you'll see in NFPA, it allows you to do remote area reductions based upon quick response sprinklers, where you don't have to calculate as many sprinklers operating as you would if it were standard coverage sprinklers. Now, why you see this more so in the United States is because we've been using quick response sprinklers for so long that everybody's very familiar with all the benefits you can get from quick response sprinklers, as opposed to using standard response sprinklers with those design reductions. So contractors try to take advantage of these reductions by using the quick response sprinklers instead of standard response sprinklers for these types of applications. Now, keep in mind, quick response sprinklers aren't beneficial in every application. For example, if you had an extra hazard occupancy, it actually has to be listed for extra hazard occupancies to use a QR sprinkler. The reason for that being is with extra hazard, now you're starting to get a lot of flammable and combustible liquids that could be introduced, and you're getting just more rapidly developing high heat fires with extra hazard applications. So in that case, if the sprinkler hasn't specifically been tested for extra hazard with a QR, you could potentially operate too many of them and exhaust a water supply. So there are a lot of benefits to quick response sprinklers, but there are still applications where a standard response sprinkler would be more beneficial to use as well. Hopefully that answers the question.
Okay, let me wrap up.
Okay.
Thank you, Sean. Igor, basicamente, a resposta basicamente é o seguinte: como, evidentemente, a resposta rápida ele aciona mais rápido, o que acontece é que você controla o incêndio logo no início. Então, com um ou dois sprinklers, você consegue apagar, né? E ao passo que se você tiver com resposta padrão, pode ser pelo fato de ser necessário mais tempo, você pode ter alastrando um pouco mais e abrindo mais sprinklers. Então, o que acontece é que isso vamos dizer assim, é uma filosofia, um senso comum, mas isso é testado, evidentemente, e aí, na prática, o que acontece é que a norma permite você fazer reduções do porte do sistema, da demanda, da demanda de água, essas coisas todas, quando você usa o sprinkler de resposta rápida, porque ele vai combater mais rápido, né? Então vai precisar de menos água, porque vai abrir menos sprinklers. Então, basicamente, essa é a lógica, né? O sprinkler em si é um pouco mais caro, só que o sistema ele reduz e você ganha no contexto, no todo. E o que ele comentou é que isso é mais comum nos Estados Unidos do que no Brasil, porque lá o pessoal já usa isso há muito tempo, então é uma informação mais difundida, né? Sim. E no Brasil as pessoas estão mais acostumadas a ver o custo unitário da peça, né? Sem levar em conta o escopo inteiro da instalação, mas que isso é muito benéfico, né? Ele comentou que tem instaladores que se beneficiam disso, projetistas, clientes finais e etc., né? Aí, da minha parte aqui pela ABSpk, eu posso dizer que o uso do resposta rápida tem aumentado com o tempo, mas ainda, pelo menos aqui para a ABSpk, ainda é inferior à metade, tá? E é uma discussão bem interessante essa, né? Porque o produto em si ele é um pouco mais caro, só que o sistema fica mais em conta, né? E aí só que para o pessoal conseguir se aproveitar desse benefício, tem que ter o conhecimento aí, né, para fazer as reduções do escopo. E nisso aí a gente está à disposição para esclarecer quaisquer dúvidas.
Maravilha, Igor. Obrigado. Thank you, Sean. Vamos para a última pergunta e depois eu vou para os recados finais, tá bom, pessoal? Última questão. E antes da questão, Igor, eu queria ressaltar que o André, ele colocou aqui se poderiam deixar os links e contatos da Viking, os representantes da Viking aqui no Brasil. Se você pode deixar ali no chat.
Posso. O meu e-mail é bem fácil, tá? É igor@ABSpk, Igor normal, IGOR, @ABSpk, tá aqui minha camisa, tá? .com.br e tem os contatos aqui da empresa, mas eu vou deixar, vocês podem fixar.
Tá. Vamos lá, última pergunta. Estamos chegando a 1h16, acredito que até 1h20 ali, um tempo bom, a gente encerra a transmissão, eu faço as considerações finais. Última pergunta é do Gilberto Neto. Ele pergunta: a Viking tem uma lista mais extensa para aplicações em ambientes refrigerados, congelantes, correto? Poderia explanar, detalhar um pouco mais sobre essa aplicação?
Ok. Sean, the last question, the guy is asking that about our cold storage and freezing applications. Okay, not cold storage, cold places, not storage. Okay, Viking has the broadest line of sprinklers for cold places and also freezing places. Can you please explain a little more? I think here we could tell about storage as well.
Yeah, so when you're looking at cold storage applications or even just non-storage applications where you have an area that cannot be maintained at or above 40 degrees, most of the time you're looking at dry sprinklers, especially if it's a pendant. So connecting to a wet system, going down into the non-heated area or out into the non-heated area. So that's why we have dry sprinklers starting at a 5.6 K factor in the range all the way up to, our 25.2 K factor dry ESFR sprinkler with many different K factors in between, because whether it's storage or non-storage, there's plenty of applications where you have non-heated areas where dry sprinklers are used. Now, outside of dry sprinklers, what you would see in these type of applications would be upright sprinklers being used. And commonly, when upright sprinklers are being used, you're looking at, depending upon the area being protected and what the sensitivity and value is of the equipment or product being protected in the hazard, you could potentially be looking at a double interlock pre-action system when using the upright sprinklers for protecting these areas. Whereas if it's just a parking garage that's in a non-heated area, you're still using uprights, but now in that application, you might be using the dry system. So when you look at Viking uprights, we have every K factor that could be beneficial for these type of applications, from the very smallest size all the way up to the largest size that you pretty much see on the market today. So in any type of range, any type of hazard, any type of application, for the most part, we are going to have a sprinkler available, and we strive to meet any type of instance that you might come across for an application, and that's why we offer so many different options for protection in these type of areas.
Okay, Sean, let me wrap up. Igor, o Sean explicou que a Viking tem uma linha muito extensa, desde sprinkler, desde sistema, e não é só o sprinkler, né? É o sistema inteiro. Então, desde sistemas como, por exemplo, um estacionamento numa área que não é aquecida, aí vale uma pausa aqui, tá? A Viking fica no Michigan, é uma região muito próxima do Canadá, é muito frio, tá? E essa região dos Estados Unidos e Canadá também, ela está sujeita a congelamento pelo próprio meio ambiente, tá? Então tem neve, essas coisas todas. Então um sistema de sprinkler de um estacionamento, por exemplo, que seja um prédio aberto, né? Imagina um estacionamento, garagem de um aeroporto, que é todo aberto assim, tá? Esse sistema está sujeito a congelar. Então, assim, o sprinkler em si é o mesmo, em geral se usa upright, né, como que o Sean tá comentando. O sprinkler em si é o mesmo, só que você precisa de válvulas, né? Então, por exemplo, no caso de um estacionamento, você tem uma válvula dry, né, que é um sistema mais simples. Para um armazém refrigerado, você tem as válvulas de preação, né? Com duplo interlock, enfim, tem uma série de... Então, dependendo do sistema que você trabalha, se for um caso simples, como estacionamento, ou se for um caso complicado, como um galpão de armazenamento, né, que está sujeito a congelamento, ou no caso da realidade brasileira, um galpão frigorífico, né, aí você tem uma série de sprinklers diferentes que cobrem essa área toda, né. Tem as certificações deles para wet pipe ou dry pipe, né, com água ou seco, e dependendo do sistema tem um monitoramento, mas a Viking tem a maior oferta, né, desses sprinklers todos, chegando até o caso do produto mais recente, que é um dry pendant, que é o K25 Dry SFR para sistemas de armazenagem em galpão frigorífico. Tá, Igor, eu acho que só tem um ponto que eu já atendi aqui no Brasil. Algumas pessoas pensam que pelo fato de você estar num ambiente refrigerado ou congelado, o incêndio não pode ocorrer, tá? Isso é um erro muito comum aqui no Brasil, né? Porque a gente não tem contato com área realmente muito fria, que nem nos Estados Unidos. Então eu vou pedir ao Sean só para completar esse ponto, tudo bem?
Tudo bem, com certeza.
Sean, just another point is that here in Brazil we essentially don't have snow, and snow in places freezing conditions, and it's very common, unfortunately, that some people think that cold storage in the cold storage sprinklers are not necessary because it's a freezing environment, and that fire will not develop within that freezing environment. And we all know that's a mistake, but can you please give some information about that?
Yeah, that's definitely not the accurate information, because all the packaging for product in cold storage, what they're stored on, and you see plastic pallets, you see plastic packaging, styrofoam packaging. There's a lot of higher combustibles that could be ignited in a cooler freezer application. And once they get going pretty quickly there. Now, the plastic pallet itself is not necessarily what's going to start the fire, but what you see in these type of applications, the most common place for a fire to start would be all your automatic defrosters. If you think about the automatic defrosters that are used in these large cooler and freezer applications, sometimes there's multiple automatic defrosters, and those run pretty hot. And electrical fires can start in a cooler or freezer, and once they start, they ignite all the plastic materials that are being stored in there for the pallets and the packaging as well. So your automatic defrosters definitely pose a fire challenge, as they run very hot, and there's a lot of electrical components that are tied into that could potentially cause a fire.
Ok. Igor, o Sean comentou que é um erro comum, porque pouca gente está habituado com isso, mas que, por exemplo, no caso de armazém frigorífico, que é o caso do Brasil, né? Esses sistemas, eles têm um sistema de degelo, né? E são máquinas muito grandes, e elas circulam ar quente, né? Para evitar que forme formação de gelo mesmo, né? Porque o ar tem umidade, e esse gelo, se ele for crescendo, ele vai pesando, ele pode até causar um dano estrutural, coisa assim, no equipamento de refrigeração. E devido a isso, você tem os ciclos de degelo, né? E circular quente. E são máquinas grandes, né? Trabalhando a quente, mesmo dentro de um galpão frio. E essas máquinas têm componentes eletrônicos, e a maioria dos incêndios são relacionados, em galpão frigorífico, são relacionados ao sistema de degelo, né? E isso começa basicamente pelo plástico e depois vai se alastrando, e é um incêndio bem complicado, independente da temperatura ser congelante, né? Pega fogo mesmo, tá? Tem gente que ainda duvida, mas a gente está aí à disposição para esclarecer.
Maravilha, excelente explicação, extrema importância, Igor. Vamos finalizar? Excelente apresentação, chegamos a quase 1h30, o público bem ativo, já deixo os agradecimentos para todos que acompanharam até o final. E em nome da ABSpk, já quero deixar os agradecimentos. Thank you, Sean, graças, Alejandro, obrigado, Igor, por todo o suporte. Em nome da ABSpk, agradecemos a participação de vocês, de suma importância, e quem sabe conseguimos marcar outros encontros, outras apresentações, inclusive presencialmente aqui no Brasil. Tá? Muito obrigado a vocês. Vou para a reta final, vou dar alguns recados, pessoal, aguardem um pouquinho, mas deixo meus agradecimentos aos convidados de hoje. Obrigado. Vamos lá. Pessoal, agradecemos, né, todos nós aqui que participamos, a ABSpk, para você que participou, mandou sua pergunta, mandou seu comentário. Fica aqui o convite para o último encontro. Tivemos uma alteração de data, seria na próxima terça-feira, mas mudamos para o dia 2 de dezembro. Inclusive, esse tema será tratado, projetos especiais, como projetos em câmeras frigoríficas, projetos que requerem um cuidado maior no seu dimensionamento. Tá? Fica o convite, será com Edgar da Taiko. Teremos outras apresentações também da ABSpk para falar sobre a Expo Incêndio no ano de 2025. Fica o convite. Dentro das mídias digitais, das comunicações, vai ter toda a orientação para você que queira acompanhar, tá bom? Então, em nome de todos, agradeço a participação por mais esse encontro e desejo a todos um excelente final de semana. Sigam as redes sociais da ABSpk, Instagram, YouTube, LinkedIn, e muito obrigado. Até a próxima.